Okay, so this lesson is called um, 4-6, but it is cpctc and paragraph proofs. Okay, paragraph proofs. Okay. So if I have a triangle, look, I put my freehand shape tool on my palette up here. Except now I can't find it. Oh, there it is. Okay. So if I have two triangles, well, okay, there. And I tell you this. Say I say this is congruent to this is congruent to this is congruent to this, and this is congruent to this. Are these two triangles congruent?
Yes.
By what? Side angle side. Okay. Is this piece congruent to this piece?
Yes.
Yes, because if they're congruent, then all the other pieces have to be congruent, right? A triangle has 6 pieces, okay? It has 3 angles and it has 3 sides. So once I've proven that those two triangles are congruent, I can say that any of their other parts are congruent. So say I'm given this, if this angle is 37 degrees, what does this angle have to be over here? 37 degrees, okay? Which is kind of a nice thing because I use examples, say you're in it's a kind of a simplistic example if you're working like at the car parts store or something like that. If they're making like a door or something for your car, right? They don't measure every single angle and every single length, right? They want to measure like the minimal lengths and angles that they need to do to make a copy of that one, right? So they're not going to measure every single teeny little piece, but if I know that this shape is congruent to this shape, then I know that this angle has to be congruent to this angle. I know that this angle over here has to be congruent to this angle over here, and so on. And that's known as cpctc. That stands for something, okay? cpctc stands for corresponding parts of congruent triangles are congruent. Okay? Corresponding means congruent. Corresponding means they line up, right? So it basically means if I know that these triangles are congruent, then I know that these other pieces are congruent, that these other pieces are congruent, that these other pieces are congruent. Okay? And you use that a whole lot in proofs. Okay? And we're going to start with a little paragraph proof. Can I move on to the next thing? Okay. So say I had a picture. Where's my graph paper? So look at my cool street. I love this tool now. I have it right there. I can go like this and draw this and draw this. And I'm going to label this figure A, B, A, C, B, D. A, C, B, D. And I think I put an M in the middle. There. Okay. And I'm going to tell you that this piece is congruent to this piece. And this is parallel. Remember those little angly brackets mean parallel. And then I'm going to ask you, is AD congruent to BC. Is AD congruent to BC? Look at the picture, and here's where you have to use deductive reasoning and put together everything that we've kind of been talking about in the last unit or so. So I'm asking you, is this piece congruent to this piece? Now again, these things don't mean congruent. Those things mean what? Parallel. Who can put together kind of a reasonable argument that tells me why that might be true? Yes, Ben.
Yeah, so I think triangles are congruent.
Why?
Because of the vertical angles.
Right. Okay.
Both the angles are congruent.
Okay. So he says these angles, right?
Yeah.
Okay. Vertical angles are congruent.
And the alternate interior angles.
Very nice. Because these are parallel, which alternate interior angles do you want to use?
Both.
Yep, that's what he's, so you could use either this one or this one, right? Or so this one, and this one, right? Those are alternate interior angles. I could have also used this one and this one. Now why are the triangles congruent?
Because of the angle side angle.
Angle, side angle. Because those triangles are congruent by angle, side angle, what would have to be true about these two pieces?
All parts of the same.
Right? Those are the same because of that cpctc thing. Okay, so that's kind of, right now we're not writing up like a formal proof, we're just using what they call a paragraph proof. Okay, so again what he said, well, in order for AD to be congruent to BC, you kind of work backwards, right? The triangles would have to be congruent. Well, let's see what I know. I know these are parallel, so these alternate interior angles have to be congruent. I also know about vertical angles, and those are congruent, right? And I could have also used these alternate interior angles, right? Whenever you see a Z shape and lines are parallel, this angle here, right? This angle here is congruent to this angle here as well. So I could have used angle, side angle. I could have also used angle, angle, side. See it? Okay? So when you write this up, it kind of looks like this. Okay? So you're writing a little paragraph. It says, well, given, so you're given that, so right now we're just writing it in words. Given that BM is congruent to AM, because that was shown in the picture, right? Then you could say something, since CB is parallel, this means parallel, I'm starting to use, to DA, okay? Alternate interior angles let's just call this, I'm gonna cheat. I'm gonna call this angle 1 and angle 2, okay? Alternate interior angles 1 and 2 are congruent, okay? Also, I could have also just used alternate interior angles. I could have gone angle, angle, side, right? But I'm going to use the vertical angles, okay? Also, vertical angles, I'm going to call this, I'm going to cheat again. I'm going to call this angle 3 and angle 4, okay? Also, vertical angles 3 and 4 are congruent, okay? Therefore, triangle, we'll call it CBD, is congruent oh no, it's not CBD, sorry, CBM is congruent to triangle, if I call this CBM, I have to go corresponding. DAM. Uh-oh. The bad word. Damn, that's not a bad word. Damn. Okay? Therefore, is by, and you have to say why. By angle, side angle. ASA. And finally, you could say that side C, side AD is congruent to side BC because of what? Because of C, P, C, T, C, period. Okay? Do you get that? So that's kind of what we're doing in this section. We're writing paragraph 2. So you ask this question, and then the answer is, yeah, I can first, I look at what I'm given, I could try to prove the triangle is congruent, and therefore I could go on and prove that. Okay? Got it? Kind of? Got it. We're going to do another one. All right. So another example. This one's a little confusing-er. More confusing? More confusing. Confusing-er. That's not a word, is it? Confusing-er?
It could work.
It could work. I'm going to draw a triangle. Oh, no. I'm not going to draw it with that. I want to get my cool freehand shape tool. There it is. Triangle. Now I'm going to do this in my triangle. Whoa. Isn't this, I bet you wish you had one of these. Let's see if that makes a straight line. Oh, it didn't recognize that. You can't go that, you can't be that squiggly, I don't think. So let's try again. It has to be somewhat straight. There we go. All right. So I'm going to call this triangle ABC. I'm going to call this triangle ABC. I'm going to call these 2 points D and E. D and E. Okay. And then I am going to tell you this. I'm going to tell you that this is congruent to this. I'm going to tell you also that this up here is congruent to this up here. And then I'm going to ask you, okay, is AE, where's AE? Is AE congruent to BD? Who thinks they could think of an argument to, like he said, to separate out the triangle? So it might be helpful to where's my tool here? Is that my tool? That's my tool. If I were to take this triangle on the one of the triangles, I'll try to draw it. It's not a very good drawing. But if I call this triangle AEB, right? Here's triangle AEB. This triangle right here, even though it's not exactly the same shape. And this triangle here, I'll try to draw it a little bit better. Okay? I'm going to go like, how do I draw that triangle? Like this. Oh, that's really bad. Oh, it didn't even look like a triangle. Let's try again. Oh, back again. Let's try one more time. Okay, so this triangle here, I'll try to draw a little bit better. There, that should be good. Okay, so this triangle here, I'm going to call triangle ADB, right? And I'm given that angle E is congruent to angle D, right? I'm also given that angle, whatever this little, I'm going to call this angle 1 and this angle 2. Here's angle 1 down here, right? It should be called BAE, right? BAE is congruent to angle ABD, right? So this angle 1 is congruent to this angle 2. And then from this picture, do you see that they both have side AB in them? Yes? AB, right? Okay. And so angle, angle, side, angle, angle, side. Therefore, segment AE has to be congruent to BA. So writing it up, should we write it up? Or can you do that? You don't want me to write it up, Ashley? Okay. Let's do it just kind of quick, okay? So so you would say something like I'm going to call this 3 and 4 just to make it quicker, okay? Angle 3 congruent to angle 4 because it's given, is given, okay? Angle 1 is congruent to angle 2 is also given in the picture, okay? You could say that side AB is congruent to itself, right? Is congruent to, that really means congruent to itself, right? Then I'm going to use this fancy symbol. Anyone know what this means? That means therefore, okay? This means therefore in math speak, okay? Therefore, triangle ABE, Abe, hey, it's honest, okay? ABE is going to be congruent to, oh, Abe is honest and the other triangle is bad. Wow, Abe is congruent to bad, okay? Because of ASA, no, AAS, okay? Finally, or you don't have to say finally, you could say therefore again, okay? Finally, AE is congruent to BD because cpctc, okay? So that's kind of, am I still recording? Yeah, I'm still recording.